Welcome to our presentation on sets and power sets. First off, what exactly is a set? A set is represented by a collection of data that has a common property. For instance, the faces on a coin, integers, characters, anything of that nature as long as it's uniform. And each member of a set is called an element. Sets are typically denoted by a single capital letter, with the elements surrounded by brackets and separated by commas. Sets are also not required to be made up of purely integers. They can have parameters as well. This is called a set former. These are some of the most common parameters. And this example at the bottom states that the set S contains the variable x, such that x contains even integers. Next up, we have operations on sets. First operation, intersection, is denoted by the upside down capital U. An intersection is used to describe objects that are common to two or more sets. For example, A intersection B yields 3 and 4, since they are the only elements common to both A and B. The next operation, union, is denoted by a capital U. And union is used to describe objects that are in one set or in another set, essentially combining the two sets together. And the last operation, difference, is denoted by a subtraction sign. Differences are used to describe objects that remain when members of one set are removed from another. For example, A difference B yields 1 and 2 since they are the only members in A that were not present in B. Next up, we have subsets. And a subset must contain elements of another set for it to be considered a subset. A proper subset must have fewer elements than the parent set, while an ordinary subset could have the same amount. And a subset can consist of an empty set or the complete parent set. And finally, we have power sets. And a power set simply consists of all the subsets of a set. So for example, the set S would have a power set that consists of the empty set, each individual member of S, and every combination of S, including the full set. A power set will always have a number of elements equal to 2 raised to the number of elements in the original set. Therefore, if a set has 3 members, then the power set of that set will always have 2 to the third, or 8 members. And this is just one example of how power sets can be useful for computer science.